What do stargazers have found? Utilizing our new 10 billion toy, it will be years before that undertaking turns into a reality. On the off chance that it goes as planned, the journey to Proxima B will take around 20 years. So, reasonably, it will be quite a few years before we can confirm if there is indeed life on that planet. The age-old question, are we really alone in this universe? The James Webb Space Telescope has found some alarmingly human-like things far away from Earth that lead us closer to the answer. Our search for life beyond us has been widespread throughout every human civilization to such an extent that we have a great many media, writings, and speculations regarding this matter. Our marvel regarding our place and loneliness in the universe has been consistent, as though it is imbued within us to constantly look for a companion, no matter how alien they might be. We could actually be getting increasingly close to the answers we genuinely need, but are they really the answers we are searching for, or are they much more startling? Join us as we explore the latest revelations in the domains of worlds and planets on the journey to find something we may not be ready to observe, lights far, far away. Researchers have found what could be the most pivotal discovery in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, an extremely interesting theoretical inquiry was raised about the capabilities of our technology. The question was whether, in the future, our telescopes could identify artificial light on another planet, for instance, Proxima B. Proxima B, the nearest exoplanet to Earth, is in the habitable zone of our closest neighbor, the small star Proxima Centauri, around 425 light-years away. Since the exoplanet is multiple times closer to its star than Earth is from the Sun, Proxima B was believed to be tidally locked, with a permanent day side and night side, similar to our Moon, which always faces Earth. A theoretical technological civilization on Proxima B could move heat and power from the day side to the night side using photovoltaic cells that generate power from starlight. Consequently, in a paper with Mons Lingam as one of the researchers, it was shown that a significant inclusion of the day side by solar panels could be detected with future telescopes. Since JWST is further advanced, it would allow us to expand our search for artificial lights to habitable exoplanets like Proxima B. Now, in 2024, it is possible that the James Webb Space Telescope did just that. Utilizing its higher sensitivity and greater range of capabilities, the JWST may have found the lights we were searching for, potentially propelling us into another great wave of human development. But first, let us delve into the universe of planets and exoplanets to figure out how all this was even conceivable. James Webb's mission investigates Proxima Centauri B's mysteries. Since forever ago, people have pondered the concept of the universe. What are we? Where do we come from? And where do we go? These are common yet profoundly challenging questions. Humanity has tried to answer them since we gained consciousness. Now, in the era of dramatic technological advancement, one wonders whether we are any closer to any of the above questions. If you were to ask a philosopher, he would likely say we are currently at level 0 of understanding ourselves in the universe. However, ask an astronomer the same thing and watch him bounce all over in excitement as he rushes to tell you the latest discoveries made about the universe using their clever tools. These tools, albeit not given much attention by the average public, are quite literally a sign of human advancement itself. We now have the universe readily available at our fingertips, and it is time we move forward and grasp it. One such method of doing that has been derived by researchers and astronomers. It is through the technology we tackle. A particular formation of that technology is now responsible for the new discovery of what could be light on an alternate planet light-years away. Indeed, we're discussing the James Webb Space Telescope. The James Webb Space Telescope is a creation born out of the traditions of human campaigns into space to answer some ever-present questions. Are we alone? Who is out there? Where do we start, and where do we end? Well, this infrared space science instrument has already begun addressing these inquiries. What even is Proxima B? Proxima Centauri B, or simply Proxima B, is sometimes referred to as Alpha Centauri Cb. It is a super-Earth exoplanet that orbits an M-type star. Super-Earth exoplanets are a class of planets that are larger than Earth but lighter than ice giants like Neptune and Uranus. They are genuinely unique. They can be composed of gas, rock, or even a mix of both, and their sizes can range from 2 times the size of Earth all the way to multiple times its mass. With respect to Proxima B, it is a super-Earth and an exoplanet, meaning that it is a planet that lies outside the solar system. The first possible evidence of an exoplanet was found in 1917, however, it garnered little interest and acceptance. The first confirmed discovery occurred in 1992, leaving researchers astounded. Another exoplanet, identified in 1988, was confirmed in 2023. As of April 1, 2024, there are 5,653 confirmed exoplanets and 4,161 planetary systems, of which 896 systems have more than one planet. These magnificent discoveries are orbiting an M-type star. To understand the M-type star, you need to comprehend the red dwarf. A red dwarf is the smallest type of star in the main sequence, hence the name. In the vicinity of the Sun, red dwarfs are by far the most common type of star found in the Milky Way. They have extremely low luminosity, and since luminosity is one of our main tools for planet detection and other types of deductions, red dwarfs are not that easy to notice. These subtle stars have variable definitions and names depending on their temperatures and sizes. For instance, M-dwarf stars or M-type main sequence stars yield a maximum temperature of 3000 Kelvin, thus giving them their name and characteristics. Returning to Proxima B, its mass is known to be equivalent to 1.07 Earth masses. Curiously, it only takes 11.2 days to complete one orbit around its star, compared to our 365.25 days. You can estimate the size of the star Proxima B is orbiting. Amazingly, under the measurement of the whole electromagnetic spectrum, the star has a total luminosity of only about 16% that of the Sun. Furthermore, in the visible light range, its luminosity appears to dim much more, as it emits only 0.56% of the Sun's luminosity in the visible light range, radiating a significantly lesser amount of light energy when compared to the Sun. More than 85% of its emitted energy is in the form of infrared radiation. Revelation was reported way back in 2016. You may be asking, why Proxima B? A large number of stars, planets, and cosmic systems exist, so for what reason are we so focused on this specific heavenly body? Well, there are a couple of reasons that add to the distinct fascination space experts have in this place. As a matter of some importance, Proxima B is the nearest known star to our Sun, and by definition, it is about 4.2 light-years away. This is a major number to us Earthlings in the grand scheme of the universe. It is a simple blip. Consequently, Proxima B, our nearest realized star, is high up on the need list right now. It is also part of the triple star system called Alpha Centauri. Although Proxima B's radiance is extremely low, the actual system appears as quite possibly one of the most brilliant heavenly bodies in the night sky, coming in just behind two others called Sirius and Canopus. Anyway, the most intriguing thing about Proxima B is that it could possibly be habitable since it falls within the habitable zone. The potential outcomes surrounding this star are unending, and thus astronomers have taken on the endeavor to explore the depths and limits of the potential of this star. That is where the James Webb Space Telescope, JWST, comes in. The 4 critical objectives of the JWST are to look for light from the first stars and galaxies that formed in the universe after the Big Bang, study galaxy formation and evolution, grasp star and planet formation, and focus on planetary systems and the origins of life. As the JWST continues its investigation of the SET exoplanet, we get increasingly close to the fulfillment of these missions, from SETI to exoplanets, searching for extraterrestrial life. So what exactly is SETI thinking about? Humans have forever been an inquisitive species, poking and pushing into literally everything that moves and doesn't move. It seems to make sense that a journey like SETI came into existence on such a huge scale. Imagine that God has orchestrated a grand cosmic expedition, but with a twist of gold, we are tasked with being on the lookout for signals, more specifically, electromagnetic whispers from civilizations beyond anything we could ever imagine. SETI is short for Search for Extraterrestrial Intelligence, and it is our collective work to identify secure indications of intelligent life sneaking amidst the stars. Our curiosity goes on and on. Back in the mid-1900s, not long after radio technology came into human use, visionaries like Nikola Tesla and Guglielmo Marconi thought of a groundbreaking idea. They actually hoped to use these newfangled devices to connect and contact the stars. Tesla even ventured to imagine the thought of visiting Martians using his wireless transmission system. Fast forward to the swinging 60s, and we find ourselves amidst Project Ozma, the brainchild of the gutsy cosmologist Frank Drake. Equipped with a powerful radio telescope and a healthy dose of interest, Drake scanned the infinite radio transmissions for signs of something happening beyond Earth. Unfortunately, his efforts came up empty, but the search continued. Researchers all over the world tuned in their receiving antennas to the cosmic chatter. Meanwhile, over in the Soviet Union, our counterparts across the Iron Curtain were also enthused about the astronomical jabber, led by the distinguished physicist Iosif Shklovsky. Soviet researchers turned their antennas upward, looking for those elusive signs from the stars. Thus, the stage was set for a grandiose confrontation. But wait! What's this? A mysterious signal broke through the vast noise, raising the chatter and nerves to a record high. Dubbed the wow signal, it sent shockwaves through established researchers. As the years went by, the quest for celestial companions only strengthened, from SETI to the grand Project Cyclops. Researchers went all out in their mission to unravel the enormous puzzle. Then, in a fortunate turn of events, or perhaps a coincidence, a coded radio transmission from Mars graced our Hubble telescopes, reigniting interest once again. But what does that investigation truly look like now, and how far have humans advanced regarding space campaigns? Lights on Proxima B. In a 2021 research paper titled Detectability of Artificial Lights from Proxima B, scientists Alice Abrahams and Abraham L. set out to investigate the potential for recognizing artificial lights originating from the dark side of Proxima B. Since Proxima B is a planet located in the habitable zone of its star, the study aimed to assess whether Proxima B might be capable of supporting intelligent life and how to detect it. After highlighting Proxima B's importance as an objective in the search for extraterrestrial life, they expanded on a juicy but somewhat startling point of interest: the ongoing provisional radio transmission detection from Proxima B's vicinity. It's not ongoing, as it was received yesterday, but when your area of research is strict space, where information takes light years to travel, everything is an advancement, creating a huge buzz among the science and astronomy fan community. The provisional radio signal added another layer of intrigue, yet a thrilling mystery that astronomers can hardly wait to uncover. The signal was identified by the Advancement Listen project and represents a potential contender for an extraterrestrial radio emission originating from the vicinity of Proxima Centauri, the host star of Proxima B. The Advancement Listen project, launched in 2015, was designed to study the sky for signals indicative of technological civilizations beyond Earth. It aims to break through the barriers of space and listen for any form of communication by utilizing state-of-the-art radio telescopes and data analysis techniques. The project examined vast areas of the electromagnetic spectrum, looking for irregular signals that cannot be readily explained by normal phenomena. This search has continued for quite a while, especially regarding the provisional radio transmission from Proxima B. The story is quite compelling. Astronomers working on the project identified a narrowband emission at a frequency of approximately 982 MHz. This frequency falls within the range commonly associated with artificial radio transmissions. Transmissions, for example, those utilized for correspondence purposes on Earth, were an intriguing revelation that opened the doorway to an entirely separate domain of conceivable outcomes. Despite the fact that the noticed signal has not been definitively credited to an extraterrestrial origin and may have alternative explanations, the discovery is still a significant outcome in mankind's history. With the signal established, now came an opportunity to evaluate the call. The Advancement Listen team completely led follow-up observations as well as data analysis to investigate the signal further. The objective was to assess its probability of being of extraterrestrial origin. Albeit the signal has been investigated to the Sun, back authoritative conclusions are not possible right now. The vast void we call the universe isn't as simple as we would like. 1,000 complications, aggravations, and obstructions from earthly sources can and will distort the results. For astronomers, they can't push ahead with distorted results since space endeavors need extreme accuracy on every part and a lot of money to be executed effectively. Committing an error based on an uncertain response is simply not an option. Yet there is always light at the end of the tunnel, and with the technology we have in our arsenal right now, we may just be closer to discovering the secrets of the universe than we suspect. The paper stresses the significance of artificial light as a potential marker of mechanical developments. Involving lights as a marker, the paper speculates that our endeavors could turn out to be truly advanced if we use such technology. Proxima B, which is firmly locked with a permanent dark side, requires artificial light for innovative livability. The study computes the light curve by taking into account various factors. These factors could be the planet's range, the host star's radius, orbital period, or orbital inclination. This is all done to assess how effectively we can distinguish the said artificial lights. It also describes the measurement of light curves utilizing the exoplanetary insightful reflected light curve model. It does that by introducing a parameter addressing the extent of artificial light on Proxima B's dark side by using the James Webb Space Telescope, JWST, and its near-infrared instrument. The study simulates signal-to-noise computations, again done to evaluate the feasibility of detecting artificial lights. After this, the results were gathered and analyzed, showing that the James Webb Space Telescope could distinguish lead-type artificial lights containing 5% of stellar power with roughly 85% certainty. 85% is a significant leap from other uncertain outcomes. However, the current observational band needs to be multiple times smaller just to recognize the current level of artificial light on Earth. The discussion basically proposes that Proxima B's long-lasting day and night sides might actually be illuminated by using key mirrors. This clever method could potentially enhance the visibility of artificial lights. The paper then concluded by proposing future extensions of the work. Although the future is uncertain, using future telescopes like LUVOIR could be momentous for further developed detection capabilities. JWST translates Proxima's atmosphere. One should ponder exactly how we are performing such complex computations. Millennia ago, reaching the moon seemed like a fever dream, but now we are conjecturing, calculating, and investigating planets light years away with such precision. One of the greatest images of human progress is our instruments, particularly the most powerful telescope we have, the James Webb Space Telescope, JWST. The JWST is set to revolutionize our understanding of exoplanetary climates and conditions. This also includes that of Proxima B. These aggressive plans are intended to be carried out through its advanced observational capabilities. One of the key instruments on board the JWST is the near-infrared spectrograph, NIR-SPEC. It plays a central role in identifying, sorting, and ultimately understanding exoplanetary atmospheres. That is possible because of its high sensitivity and spectral resolution. NIR-SPEC also empowers astronomers to analyze the light from far-off exoplanets, like isolating two strands of hair. This makes it easier to uncover markers of key atmospheric components like water vapor, carbon dioxide, methane, and other molecules. And you know how the adage goes, where there is water, there is life, practically all the time. Reproductions performed by these cosmologists suggest that Proxima B would have needed to wait up to 169 million years after its formation for it to be habitable. This information now makes the tenability of Proxima B incredibly questionable. Exoplanet investigation post-James Webb period, space signals, artificial lights, and superplanets to the side, is that of a dark, questionable, yet astonishing one. Not only that, with fast advancement moving the space technology work industry forward at the speed of light, it may not be long before ordinary people are walking on the moon. For instance, NASA and other private organizations currently have their sights set on the moon. NASA's aggressive but fascinating Artemis program, which has a goal of landing people on the moon in 2025, aims to start building a base. This dream of having a long-term human presence on the lunar surface is bold, without a doubt, but it is essential in a way. These aggressive plans will help NASA prepare for human space exploration beyond the Moon and even to Mars. As we dream of expanding our venture into the universe, we are also learning to appreciate and protect our own planet, Earth. The knowledge we acquire from exploring other worlds can help us understand and mitigate the impacts of climate change and other environmental challenges here on Earth. So, as we continue to explore the universe and search for signs of life beyond our solar system, we must also remember to take care of the precious planet we call home. With everything taken into account, the recent discovery and ongoing investigation of Proxima B are just a glimpse of what lies ahead in the realm of space exploration. With the James Webb Space Telescope leading the charge and new advances on the horizon, we are closer than ever to answering humanity's age-old question, are we alone in the universe? The journey might be long and challenging, but the discoveries await to be made merit each step of the way. So, let us continue to look to the stars with amazement and curiosity, knowing that the secrets of the universe are ready to be uncovered.